shape. Now we make it into speed like a ball. Something like this. Have a look. Just imagine. This is just like a ball. Half of a ball. With the radius r. Or the radius, let's say v. The velocity. And we have dv over here. Okay. Sorry for not good shape of the ball. And this actually dv. Something like that. And you know exactly from the mathematics the volume of the ball, is 4 plus 3 p radius, and the radius here is velocity. Oh, sorry. So we can also write it like this, meaning that the equation that we already get earlier, we have to multiply it by this number. Let's recall it. So meaning that our new equation is equal to dn per n is equal to, we have here v, okay, times the equation that we have already previously, m per 2p/t. Oh, sorry, you can use by k, but this must be m, small m, mass 2 times a minus a half mv squared per kt times dv. And you know dn per n per dv is the distribution of Maxwell-Boltzmann. So meaning Maxwell-Boltzmann distribution can be written by square so this is actually MB distribution. Okay, let me use this equation to calculate the calculate of root mean square speed, average speed, and most probable speed. So velocity values from Maxwell-Boltzmann distribution can be used to calculate root mean square speed, average speed, and most probable speed. Let's have a look over there on the presentation. So this is the problem. Calculate VRMS using MB distribution. So we know already the equation of Maxwell-Boltzmann distribution. So from here, we would like to count the v square. So root mean square is actually this, like this, or like this, isn't it? And this means we have to multiply this with Maxwell-Boltzmann distribution equation. So meaning that we have to count this by C square C of V, C square times V x dV x. Sorry, V dV x times dV x. Okay. So, sorry, we can rewrite again from here. C can be written by this, and this is the MB distribution. Let's have a look in the presentation. Again, we back to the presentation again. Have a look over there. We have mathematical solution. When we have as the first time, so similar to mathematical solution when we discuss about the MB distribution. So have a look the first equation on the left side. Or I can show you here in the whiteboard anyway. Let's so make it clearly, more clearer. So we have this. We have to solve this equation. Okay. So how we count this? This depend on the value of n. If n is equal to 0, then sorry, this is I. For example, this is I, not 1. If n is equal to 0, then I will be the same or equal to half v per n. When we have n is equal to 1, I equal to sign like this. When we have n equal to 2, I will be the same as equal to this. Now we straight away go to n equal to 4. I will be the same as Now we back to our equation. Have a look at our equation. Our equation is actually v square is equal to v square fv dv, and this equal to very long v m per 2p kt this time integrate V4 E and V T dV. And have a look this here. That meaning we have V powered by 4, and this meaning N is equal 4, so we have this. Okay, I think very clear now already in the presentation. You can see in the presentation over there. Sorry, this. When we find that one already I show you, then you can exactly calculate the V average V velocity square, and finally we find the V root mean square equal to that as we already calculated previously in the first meeting. Now it is your assignment. You have to do it. You have to solve it. So this is the assignment that you have to do. You can do it at home by yourself, or you can do it with your friend. We already count the root mean square speed, and now just calculate or prove the average speed with the equation like that, and the most probable speed with the equation like this. You need to remember that you can use R, capital R, the constant, instead of K. And you know that R is equal to K times Avogadro number. But this must be also remembered. You cannot forget this. When you use R, when you use R, then you have to use M, capital M. M here is mass of mole instead of M. Small case of M, that is mass of the molecule. And here the mass of the mole is equal to mass of the molecule times Avogadro number. Okay, and the values, when you find 3 of the speed, the values of the speed is given by the presentation. Have a look at the comparison. Comparison is very clear comparison. See? And when you find this, when you already integrate and derive the equation, then you can also determine the comparison of velocity values. I think our meeting today, our class today is enough. So anyone would like to ask, don't hesitate to ask me. Just email me on jaslin@ymail.com. Again, jaslin@ymail.com. Thank you very much for your attention.